Enough with the chit chat already. Okay, every multiple of 12 is a multiple of 4. That is, every element of n is an element of m. Now, this over here, this statement only tells us that n is a subset of m. That is the conclusion so far. I haven't proven that they are not equal yet. So now the next part is to prove that they are not equal. Then this is point number 1. Point number 2, but some elements of m are not in n. Example, you were saying 4. Just one example is good enough already. So this one over here tells us that n is not equal to m. So based on these two arguments, n must be a proper subset of m. Okay, write the subset properly like this. You mean this one? Why did I write this? Is that a question? Okay, I wrote this because all the elements of n, all these, they are found inside here. Since all the elements are inside m, that means it is a subset. Subset. See, there are two possible cases. Everything found inside. So it must be a subset. So since it is a subset, it could be a proper subset, it could be equal. Right? Then now the next step is to prove that they are not equal by using one example. One element is sufficient to prove that it is not equal already. Can't hear you. Need lah. Otherwise, if you just write the first point, you are telling me that n is a subset of m. You're not telling me it is a proper subset yet. If you know, no, you need to prove it to me with this information. Otherwise, you just like that write, then people also can write. Ask you to show, then you just write without any working. Then everybody also can get the mark, right? You must show me an explanation. Can? Yeah, you can. Next. Page 95. Question 3. No need list out all. You see, I only list out some. But I list out enough to show that, see, I know at the back of my mind, I need to show like 2 or 3. One is not enough to conclude. You need to write a sentence so that I know what's going through your mind. Otherwise, I tell you what's going to happen. If I don't write the sentence right, if I don't write all these things, then looking at the same question, you guys are going to list it out. Okay, everybody knows how to list, right? Then, even people who don't know what's happening, they also can write. So, m, sorry, is it m or n? So, n is a proper subset of m. You see, this is what people can do, right? Everybody knows how to list it out. Then, even though they don't know why, everybody can just copy this last statement, right? Because that's what they want us to show. Then, do you really know what's happening? I mean, as a teacher, this student may not know what's happening, what? You understand or not? Yeah lah. Which is the question, right? Show. Okay, you must think from our point of view. That's why, whenever it is a show question, for example, show that n is a proper subset of m. Then, this is the question. Then, the first thing that the student writes as the answer, n is a subset of, proper subset of m. I straight away give you wrong already. Even though subsequently you want to prove it to me, the moment you write the conclusion, that means you are telling me that, yeah, it is true. But you haven't proven it yet. So I'll confirm give you wrong one. Same for Pythagoras theorem, prove that it's right angle triangles, so on and so forth. Okay? So page 95, question 3. Okay, let's start with A. It says that set A contains 1, 4, 7, 12, and 16. Just these only, nothing else. Part A. Determine whether it's true or false. 1 plus 4 is an element of A. This symbol over here means element. Okay? Now 1 plus 4, we know it is obviously 5. Let's not waste time. So this is 5. Is 5 an element of A? No, it is not. So it is false. Easy? Okay, B. The set 12 and 16 is an element of A. Is it true or false? Okay, versus this, it's not very interesting. Versus 12 and 16 are elements of A. Is there a difference? Okay, look carefully, the black one. Okay, 12 and on this side, it's clear that it's 12 and 16 are elements of A. But over here, read this. What is this? Set containing 12 and 16 is an element of A. What is this? Element. Element is not a set. Element is the smallest thing already. Understand? So I cannot have a set as an element. I can have a set as a subset. I can have a set as a proper subset. I cannot have a set known as an element. Okay? So this is false. But this over here is true. Okay? Huh? Yes. Hey, you can understand it's simple English, right? Determine whether each of the statement is true or false. Okay, C. Okay, here we have the set containing 1 is a, what does this symbol mean? This one, proper subset. Okay, set 1 is a proper subset of A. True or false? True, yes, true. Okay, it is a proper subset because it is not equal. They are not equal. Okay, now for part D, A is a proper subset of A. Is that true or false? True or false? False. Yeah, it doesn't make sense, because proper subset means they cannot be equal, right? A and A are equal, yes. They use the same letter. A and A are equal. So you look, proper subset can be equal or not? Okay, now I teach you lah. Okay, A and A, set A and set A, are they equal? Yes, they are equal. So can they be proper? Cannot. So they are actually known as equal sets, or you can call them subsets. Okay, so this is false. Okay, now next E. 7 and 12 are elements of A. This one, true or false? Again, false. Same reason as before. And finally, for part F, the empty set is a proper subset of A. True or false? True by definition. And because every set contains nothing as well, right? Okay, just remember that. Okay. So next we have question 6, page 96. Page 96, question 6. Okay, so this one over here, you can practice writing it up, the universal set. Okay, it says that x is an integer. What? Inverted 3. You mean like this? You use this in physics? Okay, this one is called epsilon. It's another Greek letter. It is used for something else. What? Epsilon, yeah? Never hear before. Okay, never mind. Just do it properly, okay? So we've got x is an integer greater than 0, less than 4. Okay. So inside this universe, class, Francis, inside this universe, we've got x is an integer. So x can be negative numbers, can be 0, can be positive numbers, right? But now they give you a restriction. It must be greater than 0. It must be less than 4. So what choices do I have? Less than 4, right? So let us list it down. What's inside this set? Oh, sorry, wrong one. Okay, x is an integer, then negative 3, x and 3. Okay. Okay, so it is not difficult to list it down. If you can fully understand and appreciate this, good for you. But if you need some help, like I do, I need some help, I prefer to list it out when possible. So that I can see clearly what's inside there, what's inside this set. So can you list down all the elements for me? Negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay? Of course, if they give you a funny range, let's say until 300, we don't expect you to list everything out, because it doesn't make sense for you to spend so much time to list everything out. Okay, so this is easy enough. And we've got set A. It says that x, the elements x, has the following conditions to meet. 2x plus 1 is less than 5. So, do you understand what this means over here? We find x, yes, we can find x, but over here what this means is that A is a set. The set will contain elements. The elements are known as x. The elements are x over here, and we don't just have any values of x. First, inside my universe, what can x possibly be? Only this, right? That's inside my universe, nothing else. Okay. Now there are more conditions for set A. The x values must fulfill this condition. This is a condition to be fulfilled. Okay? Do you understand what the highlighted part means? Simple inequality, right? 2x plus 1 must be less than 5. So we have restricted our values of x further. So let us identify what they are. So 2x plus 1 is less than 5. Do your inequalities properly. 2x is less than 4, x is less than 2. Okay? So if I draw a number line for x, this is 2, it is going to be like this. Now x can take any value as long as it's less than 2, right? According to the number line. Can x be possibly equals to 1? Can? Can, right? Can it be 0? Can it be half? Can or cannot? So yes or no? No, why cannot? Because inside this universe, do fractions exist? No. So I cannot, although half is less than 2, but in my universe it doesn't exist, so I cannot have half. Okay, how about, can I have negative 3? That's x. Can, right? Can I have negative 4? Can or cannot? But negative 4 is less than 2, eh? Why cannot? Namira, negative 4 is less than 2, so why cannot? Come on. It's not in the what set? Yeah, it's not in the universal set. How do we know it's not in the universal set? See, I listed down everything in the universal set already. Inside my universe, x only ranges from negative 3 to 3. And it must be an integer. Okay? Can? So, now I am ready to list down all the elements inside A to answer part A. So A has, what is the first integer? The smallest integer for A. Negative 3, then negative 2, negative 1, 0, 1. Got 2 or no? Cannot have 2, Okay, so this is the answer for part A. Then part B is negative 4 an element of A. No. How do we prove it? We can show that 2 times of negative 4 plus 1 equals to negative 8 plus 1, negative 7. Wait, no, shouldn't be doing this. I used the wrong reasoning. Okay, no, it is not, because negative 4 is not an element of the universal set. Does this make sense? Negative 4 is not an element of the universal set. So instead of writing so much, right, I can use these symbols to help me. Alright? Sophia, okay? So next, part C. Write down common elements of A and B. Okay, what is B? B says that it has x values where x over 3 is integer. if x over 3 is an integer, right, what can x possibly be? Okay, so we said that here b will contain 3. Anything else? We need to refer back to our universal set. We can only take these values. Okay, negative 3. Any more? Any more? Something divided by 3 results in an integer. And now finally Sophia get to say you already, right? 1 divided by 3 equal to what? 0 divided by 3 is what? 0. And 0 is an integer, isn't it? So these are the possible values for x inside set B. Agree? Agree? Anything else or not? Can you imagine if they didn't tell you that the universal set contains only these values, you have so many values to try, right? And to list down. That's why the universal set only contains a specific number for you to work on. Okay, so now that I know my set B contains these 3 elements, can you tell me what are the common elements of A and B? So part C, common elements are negative 3 and 0. Okay, last question, right? Question 10. Okay, so P, black, cyan, magenta, yellow. R, 7 colors of rainbow. Okay, list the elements of set R. R equals to violet, indigo, blue, green, yellow, orange, red. Okay. Now, part B. Is white an element of R? It's so simple, right? White is not an element of R. Okay, part C. Is P a proper subset of R? Yes or no?
Yes.
Yes or no? Is P a proper subset of R? Yes, who says yes is a proper subset? Who says it's a proper subset? Okay, who says it is not a proper subset? Okay, Cindy, can you share why it is not a proper subset? You made your decision already, so let's listen. Why is it not a proper subset? Not all the colors in R is in P. You should be talking about all the colors in P, whether they are found inside R, ma. Don't go the other way around. Okay, so it sounds like some of you are changing your minds. Let's try again. Is P a proper subset of R? Yes, raise our hand. Okay, no, raise our hand. Okay. Hari, can you share why P is not a proper subset? Why is P not a proper subset? Huh? It is equal? Okay, somebody else help him? Junior, do you know? Yeah, exactly. So, because of the colors, some elements in P are not in R. Example, we've got black, cyan, and magenta. Okay? That's why it is not a proper subset. It is not even a subset. What? So like that. Okay? It is not a proper subset. In fact, it is not even a subset. Suggest a universal set for the sets P and R. A universal set. Yeah, sounds good. Colors. Okay, so inside here we've got universal set, colors. Then we've got P, we've got R. Can you tell me what's in the middle over here? Is it P and R? Yeah, okay, what's inside the middle here? Yellow. Then inside here you've got black, cyan, magenta. Then here you got your V, I, B, G, Y, O, and R. Okay? Can I move on to 4.2 already? Okay, so on Venn diagrams and complement of a set. Now this is 4.2. I've already introduced you to most of the ideas behind Venn diagrams. So we look at page 98. There are three different diagrams that they drew for you. Okay, these are three separate Venn diagrams. Inside A and B, for the first diagram, are there common elements? No common elements. Okay, now I will use this phrase. Does set A intersect set B? Intersect. Okay, good. They don't intersect. What about in the second universal set, A and B? Do they intersect? Yes. So they have some elements in common. Some. I don't know what they. Then in the final diagram, I've got A inside B. Now, can you tell me about A and B? What is the relationship between A and B? So you say A is a. Hey, don't take the easy way out. I know it's a subset. Can you be more specific? It is a proper subset of B because they are not equal, right? Okay, so these are the three of them. All the elements in A are found inside B. Okay. Now, example 10. Simple one. So inside our universal set, I've got the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Set A. Set A contains 1, 3, 5, and 7. Set B contains 5, 6, 7, 8. Should I draw set B intersecting set A, or inside set A, or separate from set A? Intersecting, is it because you see some common numbers? Okay, what are the common numbers? So B, then we put out 5 and 7. Notice that we don't need comma. We can just list the elements inside. Important point, no need comma. But what if some student, go and write down this way? Can you imagine what are some problems that when I mark I can face? When I say don't need comma, then what if a student does this? Then becomes 57, right? So can you please be clever and don't do this? So we can write it elsewhere, for example 7 over here. Okay? You're free to arrange, but make it clear that it is not 57, it's not 75. Okay, what else is found inside A that is not inside B? 1, 3. Okay, what about inside B? 8, 6. Is there any number that I missed out in the universe? So 2, 4, and 9. Just randomly put them somewhere. Understand? How about nothing? I don't need to write. Wow, very good question. Okay? So now let's try 10. Simple, right? I don't think you need more than 1 minute for this. Try 10. Then after that, you go and compare with your friends. I'm sure. So can you help me with this? Should I draw 2 circles intersecting or inside each other? Intersecting. Okay. Let's call it P and Q, right? P and Q. Okay, what is inside P but not inside Q? A. Oh, sorry, don't need the comma. F. Okay, what is found inside both P and Q? E. Anymore? D. What is found inside Q but not in anywhere else? B. And then anything else outside? C. H. G. Any more? Okay, so now I'm going to check. Look, my universal set has A, B, C, D, E, F, G, H. So I'll just count out. I'll look A, B, C, D, E, F, G, H. Okay, correct. Everything is listed down already. Okay, I see a lot of Mr. Wongs in the class already. That's a good thing. Let's do try 11. Try 11. 1 minute again for you to try. Do we need to write the empty set? No need. So this is the answer. No need, no need. The size of the circle doesn't matter. Okay, next, try 12. Try it 12. This one slightly a little more challenging for part A, but you can. Is it correct? Okay lah. Then we're done.